I'd like to talk a little bit about using the unit circle. But before we actually talk about the unit circle, I want to review just a little bit of stuff from trigonometry that you probably have seen in the past. So if we have a right triangle, I'm going to call this angle theta. This is going to be your right angle right here. Keep in mind that the side that's closest to theta is what we call the adjacent side. We call it adjacent because it's right next to theta. That's what adjacent means. It means right next to something. The side that's opposite of theta, the one that's further away, is what we call the opposite side. And the long one is our hypotenuse. So hopefully you remember your trig functions. If you don't, though, I'm going to write them out. So keep in mind that sine of theta is your opposite over your hypotenuse. Your cosine is your adjacent over the hypotenuse. And tangent is opposite over adjacent. And I'm going to go one step further and give you the reciprocal ones. So the reciprocal of sine is called cosecant. We write it as CSC. So cosecant is the hypotenuse over the opposite. The reciprocal of cosine is called secant. My way of remembering them is if you have COS backwards, then SEC is almost the same as COS. It's not the greatest way to remember it, but cosecant and secant tend to be the ones that people mix up the most. So secant is the hypotenuse over the adjacent, and then cotangent is, of course, the reciprocal of tangent, which is adjacent over opposite. So those are going to help us. Now I'd actually like to talk about what is the unit circle. So in math, we have a few different meanings of the word unit. But in general, if you see the word unit in a math class, unit tends to mean 1. So the unit circle is a circle with a radius of 1. So let's draw a picture of the unit circle. So I'm going to say this is r equals 1. That means that it is the unit circle if I have an r of 1. This is my angle theta right here. I'm going to change that angle into a triangle, actually. The other thing that's really nice to know is that this point right here has coordinates x, y. And this is a right angle. So one thing about this circle is that this side right here is the length of that is going to be whatever that x coordinate is. And then the length of this side right here is going to be whatever that y coordinate is. So actually, those two things are going to help me construct my unit circle, and then I'm also going to use what I know about sines and cosines to give myself some relationships. So the sine of that angle theta is my opposite, which notice here my opposite is y, over my hypotenuse, which notice is 1. So sine of theta is y over 1, which makes it just y. My cosine is my adjacent. My adjacent is my x, and divided by my hypotenuse, which is also 1. So cosine is going to be x. So then tangent, same idea. My opposite is y, my adjacent is x, so I get that tangent is y over x. These three things are going to help you extensively if you have a unit circle, or if you have the unit circle memorized. And there are going to be some that you will probably want to memorize. So from there we can also get our reciprocal functions. Cosecant is 1 over y. Secant is 1 over x. And tangent is x over y. So these are my three reciprocal functions. Those are also useful to know. I recommend that you don't actually memorize cosecant, secant, and tangent as I have them written now. Just remember which ones they're related to. By the way, I made a mistake here. This last one should say cotangent, not tangent. Hopefully you caught that though. The other thing I want to say is make sure that when you are doing your homework, when you're doing a test, when you're doing a quiz, that you write that theta symbol or any other Greek letter symbol for your angle. If you just write like sine equals x, that technically is not a correct mathematical statement. It's like you're taking sine of nothing, and we can't do that. So make sure that you include the theta in there. Don't forget that. That's important. So I'm going to go over the unit circle. You'll notice that I have this big, huge unit circle here. It's a little intimidating looking. There's a lot going on. I want you to keep in mind that the radius of this whole entire circle is 1. So for example, if I were to start at 0, 0 and go all the way here, that distance would be 1. And that's going to be the case all the way around this circle. So actually, without any prior knowledge, you might be able to guess what the 4 points that we have right here are. So my first one, the radius is 1, so that's going to be my x value there. My y value is 0 because I haven't gone up or down. The second one, my height is, or my y value is going to be 1, but my x value is 0. I'm right at the, on the y-axis. If I go in the other direction, keeping in mind that radius is 1, this is negative 1, 0. And then the one at the bottom is 0, negative 1. So before we do anything else, let's talk about the angles that each of these represent. So this first one right here, that's 0 degrees. If I continue along, we're not going to go the whole, we're not going to do it in order actually. This one right here, if I go all the way to that 0, 1, that's at 90 degrees. If I go all the way around right here, that's 180 degrees. And if I go further around, that's going to be 180 plus 90, which is 270 degrees. And then if I go all the way around, back to where I started at, that's 360 degrees. I don't have a space for that, but it's important to know. So those are the first ones. The next one that I have is right between 0 and 90 degrees. I have this angle right here, which is 45. That's halfway between 0 and 90. And then the next one that's right in between two is going to be 45 more than 90. You can do 90 plus 45. That's 135. And you can keep adding 45 to each of these. This is 225. And then this final one is 315. So for those ones, I want you to keep in mind that this right here is a, the 45 is this angle right here. So actually this is a 45, 45, 90 triangle. That means that the x value here and the y value there are the same. Those are equal. If this side is 1, I'm not going to go through all of the work to find this side, but we know, I'll tell you how it is. You do not need to write this. Since we know that x and y are equal, we can rewrite it like this, and then we can solve for my x value. If I do that, I find that my x value is radical 2 over 2. And so that actually is my x value. My y value here is exactly the same, so that's also radical 2 over 2. And if you go around to each of those other angles, so like for example, to 135, what we're going to do is we're not going to try to like draw a big triangle like that. That's not going to work to do that. Rather than doing that, what we're going to do is we're going to draw what's called a reference triangle. And so this little angle here, I'm going to call it alpha. That is called my reference angle. So my reference angle here is going to be what this little angle would be if I were to draw a triangle like that. That one would be 45 degrees. It's exactly between 90 and 180. So in that one, the x and y value are going to have the same, they're going to be the same values as 45 degrees with one small exception. And that exception has to do with the sign of x and y. Right now we're in the second quadrant. In this second quadrant, my x values are all negative. So actually, I'm going to have negative radical 2 over 2. My y is still positive, so I get positive radical 2 over 2. The same thing is going to happen with 225. It's going to be the same values, except that they're both negative here. And with 315, my x is going to be positive, but my y is going to be negative. So the last angles that we have are the ones that are between these values that we have now. I want you to notice that between 0 and 45, that angle is a little bit closer to 45. It is not exactly halfway between those two things. Actually, this is 30 degrees. So all of the other angles that we have are going to be either increments of 30 or 60. So the next angle is 60 degrees. The angle after that is 120, and then 150, and so on. So you can, I'm going to just go through and fill these in, but you'll either be adding 30 or 60 to each one of those. So these ones, now you can do the same thing, and I'll show you what to do. You don't need to actually write this down if you don't want to. So this right here is a it's a 30, 60, 90 triangle. If you remember with 30, 60, 90 triangles, this is 1/2. The short side is exactly half of the hypotenuse. So that height right there is going to be 1/2. That's my y value there. The long side, or the long leg, I should say, is going to be that smaller leg times radical 3 over 2. I don't know if you remember that from geometry. It was probably a few years ago. I'm not going to spend a lot of time talking about that, but that's where it comes from in case you were wondering. So the 60-degree one is going to be the same exact values, except they're going to be switched around. So for these, they're going to have the same behavior. This one right here, except that the signs are going to change. So I'll go ahead and just fill them in for you. So here is your unit circle. I did not fill in the radians. I do recommend that you go back and you fill in all of the radian values. I'll give you a few of them just so you have them, but I gave you a few of the easy ones. Now see if you can do the harder ones on your own. You can actually print out a unit circle off of the internet. They're all over the place. If you just do a Google search for a unit circle, you'll find one. And I do want to say that I do require that my students memorize this, or at least be able to reproduce it. Now, I think if you have a blank unit circle in front of you, it'll be easier to do. But you will want to be able to memorize this, or you will want to be able to reproduce it, whether you even memorize it or not. I don't recommend going around and remembering every single value, but I think it's a good idea to look for patterns. I think it's a good idea to be able to find out the 0, 90 degrees, 180, and 270 without too much trouble. And if you remember that all the ones in the very middle of the quadrant, the 45, 135, 225, 315, are going to be radical 2 over 2, radical 2 over 2. I think that's helpful for that. So this is our unit circle. I do recommend that you print one out and you have it in your notebook so that you can refer back to it because we will be using it extensively.